Hey, Topping Your Life's Math Industry, and we are going to take a look at find the x-intercept. So what we're going to be doing is we're going to be solving a series of functions and slope-intercept form equations so we can help us learn about quadratics, but not only that, how to find the x-intercept. So each line on a graph maybe we'll have a y-intercept and an x-intercept, but it depends on the line. So to find the x-intercept, a line will strike through the x-axis. So here's an equation, y equals mx plus b, or should I say y equals 2x plus 4. What it can do is, what is the x value when it strikes through the x-axis? Well, what we can do is try to put 0 into some kind of equation, because an x-intercept is going to have a number and 0 for a y. So why don't we just put 0 in for y? Because we will always get a value in for x. So we're going to put 0 equals 2x plus 4. We subtract by 4 and subtract by 4. Negative 4 equals 2x, and solve for x. Divide by 2, divide by 2. X is going to equal negative 2. So if I were to graph this on a graph, then our x-intercept is going to be negative 2, 0. Sounds kind of easy, right? Well, let's move on to the next level. So in this case scenario, it's the same kind of form, but the issue about this one is there's a fraction. So let's see what happens when we try to put 0 in for a letter y instead, to see why this works. So 0 equals negative 1 over half x minus 3. We have to add by 3 and add by 3 on this side. So 3 equals negative 1 over 2x. What can we do? If we multiply this side by 2, and multiply this side by 2, we're going to get 6 equals negative 1x, or just x. We're still not done yet. We have to divide by negative 1, and divide by negative 1, and we are going to get x equals negative 6, or negative 6, 0. So that is going to be a point in this one right over here. But sometimes, equations will get even more trickier, and sometimes they're tired of just having just one value of x. Sometimes they'll actually have to have more than that. They'll actually have 2 values of x. So, in this case scenario, it doesn't look like it's y equals mx plus b. Turns out it's y equals whatever this thing is, and also whatever that thing is. So all we need to do is do 2 steps, and that will help us get to our x. If you try to graph this onto a graph, then there's going to be 2 x-intercepts, because it's not a straight line. It could be a parabola, or a parabola. So let's see what happens. To find out what x is, we have x minus 1 multiplied by x plus 3. What we don't want to do is multiply them out. But what we do want to do is try to find what happens when we try to use the model 6, 0. Every x-intercept will have a number besides 0 on its x-coordinate, and always 0 for its y. So let's see what happens. One way we could do this is called the zero product property, or we could say ZPP. So here's what happens. X subtract that by 1 equals 0, assuming it's an x-intercept. X plus 3 equals 0, which is, assuming it's an x-intercept. Plus 1, minus 3, plus 1, and minus 3. So 0 plus 1 is 1. So x equals 1. Or should I say x equals 0 minus 3 is negative 3. So we have x equals 1 and x equals negative 3. If you ever want to try it out, you get 1 comma 0 as a point, and also negative 3 comma 0 as a point. So, sometimes that could be easy with 2 points, but other times we have even more variables coming, and sure enough, this is the hardest level of this video. Y equals x squared minus 3x plus 2. So, 1 is not y equals mx plus b. Number 2 is not 2, whatever those things are called, next to each other. What we have to do is have to make it and try to make it look like that. What I'm trying to say is, this formula looks like a standard formula, meaning it uses the idea of ax squared plus bx plus c, meaning that it follows that same formula, ax squared plus bx plus c. So what we have to try to do is try to find the x-intercepts if it was graphed on a graph. Here are 2 things. We have to do x and x, but we both have to have 2 things in the parentheses. X times x should be x squared. X times x is x squared. But the problem is, how are we going to do negative 3x plus 2? Well, here's a little trick. We can do the diamond problem. Every time you try to find 2 things when you factor, because this is called factoring, when you factor, you try to find a number that's added or the sum of negative 3. But also, you try to find the multiple of positive 2. So what could be multiplied into 2 but add to negative 3? Well, 1 and 2 is multiplied by 2, but if you put them as negatives, negative 1, negative 2 is equal to negative 3. But a negative times a negative is also a positive, meaning that these 2 numbers work. So here's what happens. The first one is negative 1, so x minus 1. The second one is negative 2, so x minus 2. And using the zero product property, it will drive us to our final answer. The x marks the spot. So, x minus 1 equals 0, and x minus 2 equals 0, plus 1, plus 2, plus 1, and plus 2. So, x equals 1, or x equals 2. But if you were to graph it, then here what the coordinates would be like. 1 comma 0 and 2 comma 0. And those are our answers for this question. I hope this video has helped you understand find the x-intercept, and not only that, understand how to factor when you have the standard formula ax squared plus bx plus c. We'll do more videos relating to this, because this is something that you'll need in algebra so you can explore and go further in higher level math courses. Thank you for watching Top Penalized Math Industry. Like and subscribe, and I hope you find the X marks the spot.